We all know ants. They're everywhere. You've seen them marching in lines, carrying food, building hills, and working together. And we admire that. The teamwork, the coordination, the way thousands of ants can work on a single task without getting in each other's way. We use them as symbols. Hard work, cooperation, strength in numbers. Busy as an ant isn't an insult, it's respect. We watch them and see organization. But here's what we don't see. We don't see how it actually works. Because when you look closer, it gets strange. The queen, who we assume is in charge, doesn't give orders, can't give orders actually. And yet, millions of ants coordinate perfectly. They build structures that last decades, find food across kilometers, defend against threats with military precision, raise millions of young, all without anyone directing them. So how does that happen? How do millions of individuals act as one organism? What's actually running the system? And let me tell you, this system is more complex and darker than you think. Let me show you. Let's start with the one ant everyone thinks is in charge, the queen. But here's the thing, she's not. She doesn't give orders, doesn't organize tasks, doesn't make decisions. She does exactly one thing. She lays eggs. And that's it. Her entire existence is reproduction, and she's built for it. Queens are larger than other ants. When they're young, they have wings. After mating, they rip them off. Don't need them anymore. And their abdomen, where eggs are produced, is massive. In some species, it's so large the queen can barely move. And she lays eggs constantly, hundreds per day in small colonies, thousands per day in large ones. Some species, like leafcutter ants, can have queens laying up to several thousand eggs daily for decades. But the queen doesn't control the colony through orders. She controls it through chemistry. Pheromones, to be precise, chemical signals that drift through the nest. Workers detect them with their antennae. And those pheromones tell the workers one thing: the queen is alive. That's the signal. Not do this or build that. Just I'm here, I'm healthy, you can keep working. And as long as workers sense that pheromone, the colony functions. But if the pheromone weakens, if the queen gets old, sick, or injured, workers notice. And they stop caring for her, stop feeding her, or they kill her outright. Because a weak queen is a liability. The colony needs a strong one, so despite being called the queen, she's not royalty. She's a tool, an egg factory, and the workers decide when that factory gets shut down. Queens can live a long time if they stay productive, 10 to 30 years in some species. Compare that to workers, who live weeks to months. The queen outlives everyone, but she's also trapped, fed by workers, groomed by workers, moved by workers if the nest relocates. She can't do anything on her own. She just exists to reproduce. And that's her entire life. Decades of laying eggs in darkness. That's the queen. Not a ruler, but a prisoner with one function. Now let's talk about the workers. These are the ants you see. Foraging, carrying food, and building trails. Workers are the backbone of the colony. And here's the key detail. They're all female. Sterile females. They can't reproduce. Their ovaries are non-functional. Evolution took away their ability to pass on genes. So, they spend their lives serving the colony. And workers make up the vast majority of the colony, 90% or more. In a colony of 1 million ants, 900,000 are workers. And every one of them has a job. But workers don't all do the same thing. Their tasks change based on age. It's called temporal polyathism. When a worker first emerges from her pupal case, she's young. Her first job is nursing. She tends the eggs, feeds the larvae, and grooms the queen. Safe work inside. After a couple weeks, she transitions. Now she's older. Her exoskeleton has hardened, so she moves to construction, digging tunnels, expanding chambers, and repairing damage. And then, after another few weeks, she gets her final job, foraging, leaving the nest, finding food. This is the most dangerous job because lots of predators are outside. Most foragers don't last long, but that's fine, because by the time a worker is old enough to forage, she's already lived most of her lifespan. She's expendable. The colony has already gotten its value from her. If she dies outside, the colony doesn't care. There are thousands more workers inside, younger, ready to replace her. Workers do everything. They're the ones feeding the queen and the soldiers. Everyone in the colony is connected through this food-sharing network. Workers also clean, because a dirty nest means disease, and disease can wipe out the colony, and workers defend. If the nest is attacked, workers swarm the threat. They bite, sting, and even sacrifice themselves if needed. One worker doesn't matter. Now soldiers. Not all ant species have soldiers, but in the ones that do, soldiers are specialized workers, bigger, stronger, and built for fighting. Their heads are larger, their mandibles, jaws are more powerful. In some species, a soldier's head is twice the size of a worker's, and those jaws can cut through other insects. Soldiers exist for one purpose: defense. They guard the nest entrances, patrol the foraging trails. When a threat appears, soldiers mobilize. They're the first line of defense, and they're willing to die. Some species have extreme soldier adaptations. Turtle ants, for example, have soldiers with flat disc-shaped heads. They use them as living doors. A soldier parks itself in a tunnel entrance, head blocking the opening. Nothing gets through. Leafcutter ants have massive soldiers with huge jaws. Some species have soldiers that spray acid, formic acid, shot from their abdomens that burns and blinds attackers. And in a few species, soldiers can even explode. When the colony is overwhelmed, soldiers rupture their own bodies, spray toxic goo everywhere. It kills the soldier, but it also kills or immobilizes attackers. It's a suicide defense. But soldiers come at a cost. They're big. That means they need more food, and they're not efficient foragers. Their huge jaws are great for fighting, but terrible for delicate tasks like carrying seeds or tending larvae. So soldiers depend entirely on workers. Workers feed them, workers care for them. A soldier can't survive alone, which means the colony has to balance. Too many soldiers, not enough workers, the colony starves. Too few soldiers, the colony gets wiped out by invaders. Evolution found the balance. Most colonies are about 5 to 10% soldiers, enough to defend. Not so many that they're a burden. Then there are the males, the drones, and they might be the most expendable caste of all. Males come from unfertilized eggs. The queen controls this. Unfertilized egg becomes male. Fertilized egg becomes female. Males exist for one reason: mating. And that's it. They don't work. They don't forage. They don't defend. They just wait. Males are produced during mating season. They have wings, and they're completely dependent on workers. Workers feed them. Workers tolerate them. When the time comes, males leave the nest, join a nuptial flight. This is a synchronized event. Colonies across the region release their males and virgin queens all at once, usually triggered by weather, after a rain or a warm, humid day. Suddenly, the air is full of flying ants trying to find virgin queens, mate in midair, and then they die. They've served their function, which is delivering sperm. Now they are no longer needed. Most don't even make it that far. They get eaten by predators or die from exhaustion. Male ants are born to mate once and die. That's the entire lifespan. Evolution decided males are disposable, and the colony agrees. Now the virgin queens. These are female ants with wings, potential future queens. They're produced during the same mating season as males, and they're bigger than workers, fed extra food by workers, building up fat reserves, because they're going to need it. When nuptial flight happens, virgin queens fly, mate with the males in the air. And here's the thing. More than 99% of them die before they even get a chance. But if a virgin queen does survive mating, she lands. The first thing she does is ripping off her wings. She doesn't need them anymore because she's never going to fly again. Then she finds a spot, digs a small chamber, and seals herself inside. Now she's completely alone. She lays her first eggs. And here's the insane part. She eats her own wing muscles for energy because they are no longer needed. So her body breaks them down and uses that energy to produce the first batch of eggs. Those eggs hatch into larvae. She feeds them with her saliva, and eventually, those larvae become tiny workers, the first generation. And once they emerge, they start working. And the colony begins. If she makes it this far, she becomes a queen. If not, if the eggs fail, if she's dug up by a predator, if she runs out of energy, she dies. Most of them do. But the ones that survive, they build colonies that last decades. So those are the 5 castes. You're born into your role, and that's what you do until you die. But how do they all work together? How does the colony decide anything? The answer? It doesn't. Not in the way we think of decisions. Instead, the colony uses quorum sensing. Basically, when enough ants are doing something, the whole colony does it. Here's an example. The nest floods. Scouts start searching for a new location. One scout finds a decent spot, returns, and recruits other scouts. They check it out. If it's good, they recruit more. The more scouts visiting a site, the stronger the chemical signal becomes. Other ants notice and start following. And once a threshold is hit, a quorum, the entire colony moves. Enough ants preferred that site. The collective made the choice. That's how colonies relocate, how they choose foraging routes, how they decide when to produce more soldiers. Simple rules creating complex decisions. And communication is all chemistry. Workers lay pheromone trails, find food, lay a trail back to the nest. Other workers smell it, follow it. The more ants using a trail, the stronger the pheromone. The shortest path gets the most traffic. It becomes the main route. Alarm pheromones work the same way. If a threat is detected, a worker releases alarm chemical. Nearby workers smell it, rush to the location, and release their own alarm pheromones. The signal spreads, and within minutes, thousands of ants swarm the threat. And recognition pheromones let ants know who belongs. Every colony has a unique chemical signature. Ants from the same colony smell right. Ants from another colony smell wrong. Smelling wrong means you're about to get jumped. Everything is completely automatic. But here's the dark truth. The thing that makes this system so efficient. Individuals don't matter at all. The colony is the organism. The ants are just cells. As long as the queen lays eggs and enough workers and soldiers survive, the system continues. Individuals can't escape. They're sterile and born into service. No possibility of starting their own colony. They work until they die. That's the deal. Evolution perfected this system over 100 million years. It works beautifully, at least for the colony, not for the ant, because this is not a society, it's a system, and every ant is locked into it. That's just how it works. But there's one specific type of ant colony where this system becomes something else entirely. Not just brutal, but absolutely terrifying. If you want to see what happens when an ant colony becomes an unstoppable killing machine, check out the latest video. Because these ants aren't just organized, they're apex predators, and every insect is terrified of them.